Hello students, there were a lot of requests from many students for me to complete the MCQ questions given in the NCERT Exemplar. So if you go through the NCERT Exemplar, under every chapter, the first exercise contains MCQ questions. So since I've already completed solving the first exercise from the first chapter, so I've decided to go ahead by solving the first exercise of every chapter to complete all the MCQs at a stretch. So moving on with the second chapter, Polynomials, exercise 2.1. I've listed out some of the important formulas which you may need. Ax squared plus bx plus c equal to 0. The sum of zeros is minus b by a. Product of zeros equals c by a. And then the required polynomial is given by x squared minus sum of zeros into x plus product of zeros. And then if the value of ABC is greater than 0 or if ABC is less than 0, we find that the zeros are always negative. And then if A is greater than 0 and C is less than 0, or if A is less than 0 and C is greater than 0, we find that the zeros are of opposite sign. So this will help us to solve the problems given in the first exercise 2.1. The first MCQ problem which you observe on the screen, if one of the zeros of the quadratic polynomial k minus 1 x squared plus kx plus 1 is minus 3, then the value of k is. So this is the polynomial given. Let me call this as p of x. I need to find the value of k, and it has already been given that one of the zeros of this quadratic polynomial is minus 3. So it is minus 3. So let me substitute p of minus 3 and equate this polynomial to 0. So p of minus 3 is equal to k minus 1 minus 3 whole square plus k into minus 3 plus 1 equal to 0. So we get k minus 1 into 9 minus k 3 plus 1 equals 0. So 9k minus 9 minus k 3 plus 1 equals 0. So here we get 9k minus 3k is 6k, and this is equal to 8. So I take 9 to the other side, it becomes plus 9, and taking 1 to the other side becomes minus 1. So k equals 4 by 3. So if you observe all the four options, I find that this corresponds to option A. So A happens to be the right answer. The second question states that a quadratic polynomial whose zeros are minus 3 and 4 is. So remember that these are the zeros of a quadratic polynomial. So given a quadratic polynomial, if I have the zeros, then the quadratic polynomial is given by this expression x squared minus sum of zeros into x plus product of zeros. Now the sum of zeros here is 4 minus 3 equals 1, and the product of zeros is minus 3 into 4, which is minus 12. So I can directly write the polynomial. So I get x squared minus sum of zeros, which is 1 into x, or I just write it as x, plus product of zeros. So it becomes minus 12. So this is the polynomial what I get. So I have x squared minus x minus 12. And now if I observe all the four options, this polynomial does not exist. So what I do is, let me divide the entire expression by 2. So x squared by 2 minus x by 2 minus 12 by 2 gives me minus 6. So this corresponds to the option C. So C happens to be the right answer. So remember, if both the zeros have been given of a quadratic equation, you can directly write the polynomial by using this expression x squared minus sum of zeros into x plus product of zeros. So keep this expression in mind. So here the right option is C. Now moving on with the third one. So third question, if the zeros of the quadratic polynomial x squared plus a plus 1 into x plus b are 2 and minus 3, then we need to find the value of a and b. So what has to be done? Just substitute the value of the zeros here in this polynomial. So P of 2 is nothing but equal to 2 square, which is 4, plus A plus 1 into 2 plus B. Or I get the equation is 2A plus B. So this is 2 plus 4, which is 6. So I get 2A plus B plus 6, and this is equal to 0. So I get one equation, 2A plus B equals minus 6. Let me call this as equation 1. Next, putting the value of x as minus 3, we get minus 3 square, which is 9, plus A plus 1 into minus 3 plus B has to be equal to 0. So here I get 9 minus 3A minus 3 plus B equal to 0. So we get the value as minus 3A plus B plus 6 equal to 0. Alright, so now let me take minus sign throughout. So I get 3A minus B minus 6 equal to 0. Or if I take this 6 to the other side, it becomes plus 6. So this is equation 2. Now let me consider equation 1 and 2 and let me add them. So if I add equation 1 and 2, B gets cancelled. So we get 5A equals 0. 6 minus 6 is 0. So A is 0. Now substitute the value of A in any one of the equations. Now 0 plus B equals minus 6. So B equals minus 6. So A is 0 and B is equal to minus 6. So for the value A equal to 0 and B equals minus 6, we find that the right option is option D. Fourth one is a very interesting one. Find the number of polynomials having the 0 as minus 2 and 5. So any polynomial can be given by this expression where the sum of zeros, now sum of zeros is nothing but minus 2 plus 5, which gives me 3, and the product of zeros is minus 2 into 5, which gives me minus 10. So I can directly write the polynomial, which is nothing but x square plus 3x minus 10 equal to 0. So this is the polynomial x square minus 3x minus 10 equal to 0. Now we know that for a polynomial, if I multiply a given polynomial by any arbitrary constant or divide it by any arbitrary constant, the value does not change. That means if p of x is multiplied by, if this polynomial is multiplied by k, an arbitrary constant, kx square plus k3x minus 10k, or if p of x is equal to x square by k plus 3x by k minus 10 by k, what happens? We find that the value of the zeros do not change. So how many polynomials can I have? I can have infinite number of polynomials depending on the value of k. So therefore, you definitely have more than 3 here. So the right option is option D. So there are infinite number of polynomials and definitely you can have more than 3 polynomials, and the right option is D. Fifth one. So given a cubic polynomial ax cubed plus bx squared plus cx plus d, and what has been given, one of the zeros of this cubic polynomial is 0, and we need to find the product of the other two zeros. Now let alpha, beta and gamma be the 3 zeros of the polynomial p of x, and it has been given that one of them is 0. Alright, so one of them is 0. And we do know that the sum of product of two zeros, that means alpha beta plus beta gamma plus alpha gamma, is nothing but equal to c by a. So this is known. So we have alpha beta plus beta gamma plus gamma alpha is equal to c by a. So one of the zeros of the cubic polynomial is 0. So let's assume that alpha is equal to 0. So we have 0 plus beta gamma plus 0 equals c by a. So hence the product of the other two zeros is nothing but c by a. So therefore beta into gamma, the product of the other two zeros, is equal to c by a. So check all the 4 options. So this corresponds to option B. If one of the zeros of the cubic polynomial x cube plus ax square plus bx plus c is -1, then we need to find the product of the other 2 zeros. So this is p of x given, which is x cube plus ax square plus bx plus c. And let alpha, comma beta, comma gamma be the zeros of the cubic polynomial p of x. Right? So these 3 are the zeros of the cubic polynomial, and we find that one of the zeros of this cubic polynomial is -1. So let's assume that alpha is equal to -1, and let me put p of -1. So p of -1 is nothing but equal to 0, which is -1 cube minus 1 whole square into a with a plus sign here, plus b into -1 plus c is equal to 0. So I get -1 plus a minus b plus c equals 0. So we have a minus b plus c equal to 1, or we get c equals 1 minus a plus b. So this is an important relation. Now we know that the product of zeros of a cubic polynomial is nothing but -1 whole cube minus 1 the whole cube, the constant term, divided by the coefficient of x cube. So we have the constant term. So what is the constant term here? It is nothing but c. The coefficient of x cube is 1. So we know that the product of zeros of a cubic polynomial is -1 the whole cube, constant term divided by coefficient of x cube. So I have -1 cube is minus c by 1 here. So therefore alpha into beta into gamma, the product of all the 3 zeros is nothing but equal to -c. And we know that one of them is -1. So -1 into beta into gamma equals -c, or beta into gamma equals plus c. And what is c? C is nothing but 1 minus a plus b given by equation 1. So what is the right answer? If I observe all the 4 options, I find that the right answer is option A, which is 1 minus a plus b, or it's been given as b minus a plus 1. Question 7. The zeros of the quadratic polynomial x square plus 99x plus 127 are. So we need to check whether they are positive or both negative, or positive negative, or they both are equal. So there are 2 methods. One is to find the value of x by using the formula minus b plus or minus root of b square minus 4ac divided by 2a. Find both the roots or both the zeros of the quadratic polynomial and then check whether they are positive or negative. Or there is an easier way. Now we know that by comparing this quadratic polynomial with the general form ax square plus bx plus c, I find that a is 1, b is 99 and c is 127. Now we know that if a, b, c, all these 3 values are greater than 0, or if all these 3 are less than 0, both the zeros are negative. Since all these 3 are greater than 0, we find that both the zeros are negative. So the right option is B, where both are negative. Next problem. The zeros of the quadratic polynomial x square plus kx plus k, where k is not equal to 0. So we need to check if they both are equal or unequal and so on. Now let us compare this polynomial with the general form ax square plus bx plus c. Now when I compare it, I get a equal to 1, b equal to k, and c also is equal to k. So now let me use the expression x equals minus b, this expression minus b is minus k, plus or minus root of b square is k square, minus 4 into a is 1 into c is k divided by 2. So I get the expression is minus k plus or minus root of k into k minus 4 divided by 2. Of course, given k is not equal to 0. Now here if we observe, now if the roots have to exist, then of course this value should not be less than 0. So therefore, what could be the value of k? Now I find that this value will not be equal to 0 if the value of k ranges from minus infinity to 0. So if the value of k is negative, I find that k is negative. So here this is negative, k minus 4 also will be negative. Negative into negative will be positive. Or if it is 0, I get this whole term to be equal to 0. So k can take a value minus infinity to 0, or k can take a value 4 to infinity. So if the value of k is 4, I find that 4 minus 4 is 0, so this becomes 0. If it is 5, 5 minus 4 is 1 into 5, so this value is positive. So any value of k which is between 1 and 4, so let's assume that the value of k is 2. So in that case, I would get 2 into 2 minus 4, which is 2 into minus 2, so I get a negative value. So I need to avoid all the values of k between 0 and 4. So therefore, the value of k will lie between minus infinity to 0, or the value of k can lie between 4 and infinity. So let's consider the first case. Now in the first case, if the value of k belongs to minus infinity to 0, that means the value of k is less than 0. The value of k is less than 0. Now when the value of k is less than 0, I find that a is 1. So a is greater than 0. So I'll write it as a greater than 0. And b is of course less than 0. C is also less than 0. So I find that if a is greater than 0 and c is less than 0, we find that zeros are of opposite sign. So zeros are of opposite sign. Let me take case 2. In case 2, if the value of k is between 4 and infinity, we find that the value of k is greater than 0. Now since the value of k is greater than 0, a is greater than 0, b is also greater than 0, and c is also greater than 0. Since all the three values of a, b and c are greater than 0, we find that both the zeros are negative. So both are negative. So if I observe all the four options, option A cannot both be positive. So definitely it is option A, because both of them cannot be positive. So here in case 2, both of them are negative. And in case 1, one is positive and one is negative. So cannot both be positive is the right option. B cannot both be negative is false, because in case 2 both of them are negative, are always unequal and are always equal. So that depends on the value of k, right? So the option is A, where cannot both be positive. So we have to consider these two cases and we'll be able to find out the right answer. So given if the zeros of the quadratic polynomial ax squared plus bx plus c, where c is not equal to 0, are equal, then so if the zeros are equal, we know that the discriminant d is equal to 0, or b square minus 4ac is equal to 0. Therefore b square is equal to 4ac, and what is ac? ac is equal to b square by 4. So you have ac equals b square by 4, or we can conclude that a into c is definitely greater than 0. Now this is possible only if a and c have the same sign, isn't it? So if a is positive, c is positive, you multiply a and c, it is greater than 0, or if a and c are both negative, it will be greater than 0. But if a is positive and c is negative, it cannot be greater than 0. So check for the options. What is the right option? The right option is both a and c have the same sign, right? So a and c should have the same sign. So the right option is option C. 10th one, if one of the zeros of the quadratic polynomial of the form x square plus ax plus b is the negative of the other, then so I have p of x, which is x square plus ax plus b. Given that one of the zeros is the negative of the other, so if one of the zeros is alpha, the other one is minus alpha, isn't it? So one is alpha, the other one is minus alpha. What about sum of zeros? The sum of zeros is alpha minus alpha, which is 0. So we get a polynomial of the form x square, the sum of zeros, which is 0. So you do not have the x term, and then you get plus minus alpha square. So I will get an expression which is the form x square plus b, or we conclude that b is equal to minus alpha square. And this is possible if and only if b is less than 0, right? So b is equal to minus alpha square, that means b is less than 0. So hence we realize that this equation, this quadratic equation, does not have a linear term because the coefficient of x is 0, and also the constant term b is negative because b has to be less than 0. So check all the 4 options. The right option is it has no linear term and the constant term is negative. So the right option is option A. So question 11 is a very easy one. Which of the following is not a graph of a quadratic polynomial? Now any quadratic polynomial is of the form ax square plus bx plus c, where a is not equal to 0. And we find that this quadratic polynomial will always correspond to a curve which is of this form, a u or an inverted u. So any quadratic equation which is the form ax square plus bx plus c will always correspond to a curve which is of the form u or an inverted u, and these curves are called as parabolas. So if you observe all the 4 options, A definitely is a parabola, B is also parabola, C is also a parabola, but D, you have a graph like this, which is not a parabola. So the option is D. So the right option is D. So this does not form the graph of a quadratic polynomial. In this lecture, we have solved all the problems from the exercise 2.1, which has been given in the NCERT Exemplar, which covers all the multiple choice questions. In the next video segment, we shall solve all the MCQ questions of chapter 3 given in NCERT Exemplar. So do not forget to like, share and subscribe, and press the bell icon to get notifications of all the further uploads, and thanks for watching.